Hello. I'd like to welcome you to our presentation that will be covering asphalt pavement evaluations. We'll also be presenting a method for rating asphalt pavements that can be helpful to you in implementing your pavement management system. Our guide in this discussion will be our Asphalt PASER Manual. Many of the details of this presentation are actually contained in the manual, along with other detailed information. The manual also has references and other useful information that you can use to actually implement your pavement management system. So you may want to follow along if you have the Asphalt PASER Manual with our discussion here. We'll start with a review of asphalt pavement distresses. And what we're trying to do here is describe the various types of distresses that you'll encounter in an asphalt pavement and link them back to the actual causes. Understanding what causes the distress, I think, is very helpful then in helping us decide what to do with the distress. That is, what kind of a maintenance or rehabilitation strategy is most appropriate. Based on this scheme of pavement evaluation, we'll then get into a fairly detailed discussion of how to rate pavements. And rating pavements is useful to you both, first of all, to set priorities in your own management and budgeting operations, but secondly, it's useful input to a more organized pavement management system. We'll begin our discussion with pavement distress and performance, and we want to link this with the actual causes. There's two general categories of causes that relate to pavement distress. The first we could describe in a general way as environmental. That is the general weathering and aging that happens to pavements as it's exposed to the sun and water and so on. Second category are more structural in nature. That is, it's related to the distress caused by loads, in particular the heavy repeated loading from trucks. For convenience, we're going to lump our pavement distress into four major categories. They are surface defects, surface deformation, cracking, and potholes and patches. If we start with our surface defects, we have three of those that we'll be talking about, and they are raveling, flushing, and polishing. Let's begin with a discussion of raveling. Raveling really is a loss of some surface pavement material due primarily to environmental causes. That is, as the pavement ages, it is less able to bond to the individual aggregate, and under traffic, you begin to see some loss of the material at the surface. It appears as a rough pavement texture. This would be slight raveling. It deteriorates into what you might call moderate raveling, where you lose even more of the pavement surface. And frankly, you just see some of the large aggregate left there. That can continue into a more severe situation where you're losing a large portion of the pavement surface. And here's a final shot of a very severely raveled pavement that has gone to the extent that they've had to actually do some patching. It's rare that you see raveling go to this extent without some other kind of distress taking place, but it's a good example of raveling. Now, because raveling is caused primarily by environmental concerns, that is oxidation of the pavement from exposure to the sun and the general aging and exposure to water, one of the effective things that we can do to prevent raveling is to put out a surface treatment, such as a chip seal. That seals off the water and the exposure to the sun and slows down the general deterioration process. Another thing I would mention, raveling should really not occur early in the life of the pavement. It should be quite a while before you see evidence of raveling. Now, if you have a poorly constructed pavement, that is, you have a lot of air voids in the pavement, you don't have a good mix design, and that allows the water and the air to penetrate the pavement, that will accelerate the raveling. So looking at the timing of the raveling in the life of the pavement and the rate at which it deteriorates gives you some clue on the original quality. Let's talk about the next surface distress, and that is flushing. Flushing is evidenced by an excess of asphalt on the surface of the pavement, and it's really due to a poor mix design. If you have excess asphalt in the pavement, under traffic, it will tend to work its way up to the surface. Very difficult to deal with. You can't really do much to it. You have to sort of wait for it to oxidize and dry out under natural aging. Sometimes an application of light sand or abrasives is helpful, but it's a defect that was caused by poor mix design, quality control of the mix initially. Next, if we look at surface polishing, that's a situation where the aggregate and the surface are worn smooth under traffic. It becomes very slippery and has obvious safety implications. Frankly, sometimes it's difficult to see a polished surface just with your naked eye. That's where some additional testing, such as friction testing, can be very helpful in determining the actual extent of traction or friction that you have in your pavements. A surface treatment such as seal coating can restore friction to your pavements as well as an overlay. Next, let's move on to surface deformations. We'll talk about rutting, shoving, settling, and frost heaves. Rutting might first occur in the wheel pads. It might be fairly shallow in nature, only a quarter or half an inch, and you might only be able to see it after a rainstorm when you see water collecting in the actual ruts. This can be a safety hazard, obviously, for the driving public, and it's an indication of surface problems probably related to the quality of the mix design and maybe the construction process. That is, if you don't get adequate compaction initially, you have more compaction under traffic, and you see slight surface rutting beginning to develop. Now, that can become more severe. If you have deep rutting, that is rutting that you can measure in the number of inches, then that's probably an indication of problems deeper down in the pavement. That is, inadequate base course or inadequate subgrades, poor drainage, all combining to cause rather severe rutting. I guess a general rule of thumb you can use is that the depth of the rutting in the surface of the pavement can help you indicate where the problems are in the pavement. Shallow rutting, generally speaking, would be up in the surface of the pavement. Deep rutting is an indicator of problems deep down in the pavement that you will usually require complete reconstruction of the pavement itself. Shoving of a pavement can occur, as you see in this particular slide. It happens to be near a railroad siding, so we're looking at large, heavy loads in this area, and it's exposed the pavement to loads that it really can't handle. It is shoved and distorted the pavement, and this isn't a pavement that would likely have to be totally rebuilt, because shoving and rippling of this extent to me would indicate that you have to rebuild the pavement and provide adequate strength for the loads that it's being exposed to. Settlement is another common problem. Here you are seeing some settlement over a highway culvert, but you see the same thing over utility cuts as well. And when you have settling, it's really an indication of, in this particular case, of a spot problem, that is a utility or a culvert installation. And it's not an indicator of pavement problems throughout. It's just a localized distress. And we have to be careful that we don't translate this into a need for some larger reconstruction when you're really looking at a localized kind of distress. Frost heave is very common in the northern parts of the United States. Here you have an example of an area that has very deep frost penetration in the center of the roadway. And quite often we have our snow piled up on the shoulder and the edge of the road that provides some insulation. So you have the center of the road heaving up more than the outside edge of the road. This can cause a longitudinal crack or distress, very typical of frost heave conditions. In addition, after the frost leaves the roadway, it doesn't always settle down into a nice smooth pavement surface anymore, and you can see rather severe distortion due to frost heave in this particular slide. Now, frost heaves are caused by problems deep in the pavement, and the solution really requires expensive reconstruction, generally removing frost-susceptible materials deep in the pavement, improving drainage, and basically reconstructing the pavement so it's more resistant to deep frost problems. Sometimes we have large objects, boulders, stones, or whatever, buried in our pavements, and with the advent of time and frost action, these objects tend to work their way to the surface. Here you've got an indication of a boulder or something that's actually pushing its way up through the surface. And you'll have to simply, dig this out and make a spot repair. But another indicator of a frost action problem. Next, I'd like to move on to cracking. There's lots of different types of cracks that occur in asphalt pavements, and frankly, they're a very good way to analyze the condition of the pavement and help us determine what is the appropriate repair or rehabilitation. Our listing of cracks includes transverse, reflective, slippage cracking, longitudinal cracks, block cracking, and alligator cracking. If we begin with transverse cracking, what we're really talking about here is a crack that's perpendicular to the center line. Those are usually the first types of cracks to appear. And if you think about an asphalt pavement, it's a long, narrow strip of asphalt. It's expanding and contracting with changes in temperature. And you will get a transverse crack developing perpendicular then to the center line. It's a normal thing. It's going to happen in all of our asphalt pavements. But as these pavements begin to age, you see the transverse cracks becoming closer together. It's a way to gauge really where you are in the life of the pavement, the spacing of the transverse cracking. Because as the pavement becomes older, the asphalt becomes more brittle, and really can't expand and contract as well as it did when it was brand new. So you see additional cracking occurring throughout the life of the pavement. This transverse cracking pattern can continue on down to where the cracks are really only a foot or less apart. Another indication that the pavement has aged and is much further along in the life. When the crack initially develops, generally it's a hairline crack, fairly tight, but with time, as the pavement expands and contracts, the cracks tend to open up. That is, the pavement is not able to fully extend back in the summer and close itself up, so you see the crack begin to open up. Here it's maybe 1/4 of an inch, and with time they can open up. Here it's 1/2 to 3/4 of an inch. And here we have an example of a crack that's quite wide. Plus something else has happened here. You notice how the pavement has settled on either side of the crack? Well, if you get water down into these cracks and saturate the base and the subgrade, and then have traffic drive over it, what happens is the traffic forces some of this water up out of the crack, and with it comes part of the base and part of the subgrade. This is called pumping. And when you have this pumping action occur, it creates a small void under the crack, and you get this actual settlement. Frankly, you don't see this kind of settlement very often. I took this slide in a parking lot where the traffic was not all that heavy. More typically, what you see when you have an open crack, you see cracking develop on either side of the initial crack. Because you soften the base and soften the subgrade under the action of traffic, you get parallel cracks, and really you start to deteriorate the pavement. Another example of deterioration of what started out to be a hairline transverse crack, and because there was no attempt to crack sealing, you get additional deterioration. Here's another kind of distress, though, that we want to take a look at. This happens to be a transverse crack, but if you can see how the pavement has raveled and is really kind of coming apart all along this crack, when you have raveling or aging extending down into the crack, this is an indicator that the pavement is much further along in its life cycle. You've got more serious deterioration. The problem with raveled cracks like this is that they're much more difficult to treat. If you try to put a thin overlay over an area that has raveling along the cracks like this, you're going to see those cracks just reflect right through in a very short period of time. So looking for raveling along with the cracks is an indicator that we're further along in the life of the pavement, and we probably have to do something a little more extensive rather than just a simple surface treatment or a very thin asphalt overlay. Another example of both raveling and transverse cracking here. It really points out the need to do crack sealing, and you want to do crack sealing early in the life of the pavement. Once it's deteriorated to this point, you really can't go in and do much in the way of simple crack sealing. It's gone too far. I believe crack sealing is a good maintenance treatment, but you must do it early in the life of the pavements and really use that technique on our best pavements. Here's another kind of cracking pattern. If you look closely at this slide, I think you can see that you've got an asphalt overlay with some age on it, but underneath is a concrete pavement. You can see a little bit of the curb sticking up on either side. Here what you're seeing is the joints and the cracks in the original concrete pavement reflecting up through the asphalt pavement. Here's another example of reflective cracking. Here's a fairly new asphalt surface on a county road. But if you look closely at the cracking pattern, you can see the outlines of the original concrete slabs. Now they've reflected up through the asphalt. You can see that they've widened the shoulder here with an asphalt area. And the cracking pattern is not due to the aging of the asphalt. It's really due to the movement of the concrete slabs underneath. So it really points out the need to know more about the pavements underneath as you're interpreting crack patterns just in the surface. For example, if we take a look at this field video, you can see an area where you have a lot of reflective cracking. This is a fairly new asphalt pavement, and they have had to do extensive crack sealing. That's probably because they had more deterioration under there and simply covered it up with an asphalt overlay rather than doing a more extensive recycling or patching. So here you have extensive cracks reflected through a new surface. This ought to be an indication to you that perhaps the maintenance technique or the repair technique selected was not the most appropriate. And if we look at it at a second case, now here the cracking is not nearly as extensive. You see just a hairline crack in the outer wheel path. But this is a brand new asphalt surface, and when you see hairline cracks developing the next year in your overlays, you know that you probably covered up something that demanded more extensive repair than simply putting an overlay over what was probably wide and raveled crack patterns. Here's another example of reflective cracking. If you look at the bottom part of the picture, you see what you might think is alligator cracking. But when you look in the center part of the slide, you can see, in fact, it's an overlay over a brick street. I guess it's a good example of the limitations of simply looking at the surface. You can learn an awful lot, but you don't know everything. If you have a history of the pavement, you know how it was constructed and what's under the pavement. That, along with your interpretation of the surface distress, goes a long ways, I think, in helping you understand what causes these distress and picking the best repair or rehabilitation treatment. Another type of cracking is called slippage cracking. Here you can see an example of where the top layer of the overlay has slid and tore loose. It's an example of slippage or separation between one layer of asphalt and the layer beneath it. Another example of slippage cracking, and it's characteristic by kind of crescent-shaped or rounded-shaped cracks. Oftentimes you'll see this near a stop sign where traffic is braking or accelerating, and it tends to pull those two layers apart. The prevention for this kind of treatment is to do a tack coat on your overlays so that you get better bonding between one layer or the other. Or if you're putting an overlay down and the surface is dirty and has mud on it, then you're likely to get this kind of slippage cracking. It doesn't indicate a strength problem with the pavement. It simply means that you have had one layer slide on the top of another. Now let's talk about longitudinal cracks. When we build asphalt pavements, there are usually longitudinal joints caused by the paver. We're putting one layer of asphalt up against another, creating a cold joint, and this joint many times will open up with time. Here's a longitudinal joint that is in pretty good shape. Here's another example of a joint between the traffic lane and the paved shoulder that was paved separately. That joint now is beginning to open up a little bit. This points out something that's helpful, I think, in thinking about longitudinal cracks. We talked about the movement that's inherent with transverse cracks when you have the pavement expanding and contracting. You really don't have that much movement in longitudinal cracks because you don't have the width of pavement there to expand and contract. So these are generally easier to fill and seal than your transverse cracks are. But if we don't keep up with some preventive maintenance on transverse and longitudinal cracks, you see raveling start to develop. Here's a case of very extensive raveling along a centerline joint or a longitudinal crack. Now, if we look more carefully at this pavement, the rest of it looks pretty good. You've got real extensive raveling just in one concentrated area right along that longitudinal joint. Frankly, that's not that uncommon because it can be difficult during the construction process to get good compaction. And if you remember, if you don't have good compaction, if you have air voids that lets more water and air into the mix, it accelerates the oxidation and deterioration, and you have raveling occurring before the rest of the pavement. It really pays to pay attention to the construction details and get good compaction on our longitudinal joints. Because if you don't, this is a real maintenance headache. You've got a pavement that's essentially in good shape with one narrow strip that is now causing you problems down the middle, and it's very difficult to treat from a maintenance standpoint. Here's another longitudinal crack, but frankly this is quite different. If you look closely, you can see it occurs in the traffic lane, and this is load related. That is, heavy loads have caused the pavement to crack and eventually work its way to the surface. These load related cracks start at the bottom of the pavement and work their way to the top. So when you first see signs of longitudinal cracking in the wheel pads, this is an indication that the pavement needs more strength. It is cracked under loading, and it's really quite different than when we're talking about preventative maintenance treatments. Now you've got a structural condition here, and the appropriate treatment, I believe, is to add a structural overlay where you add some strength to the pavement rather than a preventative maintenance kind of treatment. We see other examples of longitudinal cracking. Oftentimes they'll first occur along the edge of the pavement, where you have an unsupported edge, heavy traffic loads moving along can cause load-related distress along the edge of our pavements. Here's a good example of a recent overlay. If you look carefully, you can see some water collecting in the wheel paths, and you can see quite a bit of longitudinal cracking occurring from the center of the lane on out to the edge. To me, this is an example of selecting the wrong maintenance technique. I would bet you that if you could see this pavement before they overlaid it the year before, it had rutting evident, it had fairly open, wide, ravel, longitudinal cracks, saying that we needed to rebuild and strengthen this pavement, not simply put a thin asphalt overlay over it. This is an example of what not to do. We just don't have enough money in our maintenance budgets to make mistakes like this. Hopefully, if you do a good job of looking at the distress and thinking about the causes of distress, we can do a better job of selecting the appropriate maintenance or rehabilitation procedures. Another form of cracking that is evident in asphalt pavements is called block cracking. It's where you get large squares formed in your asphalt pavement. Generally, the cracks will be at right angles to each other. The blocks may start as much as 10 feet square, and with time, they get smaller and smaller. Here's an example of block cracking in an asphalt pavement. The blocks really don't line up with anything there. They're kind of random, but they show that the pavement has gone through extensive aging. And the smaller the blocks, really the further we are in the life of the pavement. Because this is caused by an aging or environmental process, this might be an excellent candidate for a surface treatment, as long as we can catch it early on in its life. If you let block cracking continue, you can get it down to a very small scale. Here we got an example of block cracking down to really just only a few inches square. Very extensive aging, and an example of a pavement that could have perhaps been treated with a surface treatment earlier on in its life. Next we'll move into another form of cracking. We call this alligator cracking. If you look in the lower part of this slide and off to the right-hand side, you can see an extensive amount of the pavement is covered by this alligator crack pattern. This is an indication that the pavement has failed. It has failed under loads. Now it might be due to poor drainage, it might be due to inadequate base course, or it might be that the pavement was well designed and constructed but simply wore out under many repeated heavy loadings. Whatever the cause, you know that when you see alligator cracking, it calls for a complete reconstruction. You have to rebuild this pavement, you have to put the strength back into it and replace the asphalt surface. Another example of alligator cracking along the outside edge of the pavement, you've got some rutting with water collected in the wheel paths here. This needs to be reconstructed and strengthened. You can't treat this with a surface treatment or a simple thin overlay. Here's an example of a pavement that has extensive alligator cracking over its entire surface. Again, an indicator of extensive aging and heavy loadings and the need for complete reconstruction. Finally, we'd like to move into talking a little bit about patching and potholes. First of all, let's look at this situation. You've got a culvert, obviously, and some settlement over the culvert, and it has been patched. You may also have some frost heave in the winter that leads to the deterioration of the pavement over the culvert. The important thing here is that this is a localized distress. It's caused by the culvert, and we shouldn't interpret this patching area here to mean that you have a pavement problem that extends over the entire pavement surface. It's strictly a localized problem. Here we have a wedge that has been placed on the outside edge of the pavement. This is a common maintenance practice where you have more distress accumulating. They'll lay in an asphalt wedge to provide some additional strengthening and to kind of restore the shape and the crown of the roadway. What I like to do is put a wedge down like this, or even make other permanent pavement repairs, and then watch their performance with time. If a repair like this lasts for a year or two with no significant distress, to me that says we have restored the pavement, and perhaps you can move then to a surface treatment, like a seal coat. But if you put down a patch or a wedge in an asphalt pavement, and within 6 months or a year you begin to see it to fail, that says really inherently this pavement is not sound, and a more extensive rebuilding is likely going to be required. So you can learn a lot by just looking at the performance of our patches and repairs. Here's an extensive area of alligator cracking, and some patching has had to be done. Now, this is an indication that you can't fix this with a simple repair. You need to dig this out, rebuild it, restore the strength, and then proceed with other repair or rehabilitation. Further examples of areas with potholes and patches, indicators of almost total pavement failure and the need for total reconstruction. This completes the background information that we prepared for the pavement evaluation. Now I'd like to move into the pavement rating segment of our video. We want to describe a rating system that we've developed that should be useful not only in your pavement evaluations, but to help you implement a pavement management system. We're using a 1 to 10 rating scale, where 10 means a brand new pavement in excellent condition, and 1 means it's totally failed. The key to the system is that the numerical rating is directly linked to the required maintenance procedure or rehabilitation. And that linking, I think, makes it a common sense rating procedure. It's the way we normally think about it. What we really want to do when we're out there looking at pavements isn't to come up with a numerical rating, really. We want to determine what's the appropriate maintenance or repair technique. So by linking that decision with our rating system becomes one that I think is relatively easy to use and very similar to what most of us are already doing. But by putting a numerical scale on it, that's very helpful input then to use in a more formalized pavement management system. As we do our rating and evaluation, to me it's helpful to think about the life of a pavement. That is, it starts out as a brand new condition, what we would call a 10, and gradually deteriorates with time and age down to a 1, which is totally failed. The time it takes to move through that life cycle really depends upon the quality of the initial construction and the amount of traffic, of course, that it's subjected to. The poorer the quality, or the more heavy traffic that we have on it, will accelerate the deterioration and shorten the overall life. But thinking about it in terms of a life of a pavement and determining where we are in the life, I think helps us better select our maintenance procedures. If we're early in the life, for example, we can do crack sealing and surface treatments. They're less expensive, but they really are intended to be applied early in the life of the pavement, before extensive deterioration has occurred. If we see distress that indicates strengthening is necessary, then that's the kind of thing that we ought to be doing, putting on thicker structural overlays. Maybe we need some more extensive base repair or milling before we can do that. That's further on in the life of the pavement. And of course, eventually you reach the point where total reconstruction is necessary. So linking where we are in the life of the pavement, our numerical scale, all goes back to what is the appropriate maintenance or repair technique. So let's begin our rating system. We start out with a 10. 10 is a brand new pavement, newly constructed, would require no maintenance whatsoever. A 9 and an 8 are pavements that, a 9 is a brand new overlay, and an 8 is a pavement that has a seal coat, a recent seal coat. Again, no maintenance would be required. A 7, in this overview, is a pavement that is a good candidate for crack sealing. That is, it's early in the life of the pavement, and a crack seal would be the appropriate maintenance treatment. If we move further on down the scale and we get into pavements rated 5 and 6, they're still in good structural condition, but they're in the need for a surface treatment. This is the time to catch it with a seal coat, for example. Pavements rated 5 and 6. If we move on down, pavements rated 4 need a structural overlay. When you get into pavements that are rated a 3, now you not only need a structural overlay, but maybe more extensive repair, some milling or patching has to be done before you can do the overlay. And finally, you get into pavements that are rated 1 and 2. Those are candidates for complete reconstruction. With that overview of the rating system, now let's go through in detail. You may look at pages 18 and 19 in the Asphalt PASER Manual if you have that with you, and we'll run through the individual descriptions. A pavement rated 10 is easy to recognize. That's a pavement that's brand new. Here we have an example of a newly constructed urban street. Everything is in great condition, obviously would need no maintenance or repair. If we go to pavements that would be rated a 9, now we're in pavements that are examples of recent asphalt overlays. Again, we would require no maintenance or repair. It's a new overlay. Another example here of an urban street. It's an overlay put in up against an existing curb in very good condition, rated a 9. If we next move to pavements that are rated an 8, we're talking about roadways that have had a recent seal coat. Here's an example of a brand new chip seal in very good condition. Here's an example of a pavement that that's had a slurry seal. It's in very good condition and therefore would be rated an 8. An example of another field application of a surface treatment. This is a seal coat that's used a black slag aggregate. Pavement's in very good condition, requires nothing to be done, would be rated an 8. Another example of a pavement that we would put in an 8 category is a new surface using a road mix. A road mix surface, it's in good condition, requires no maintenance, and would be rated an 8. Another example of a pavement that we would rate an 8, it has some life on it. It's not a recent overlay or brand new, but it has some life on it, but is in excellent condition, and we would rate this pavement an 8. Next, I'd like to move on and we'll discuss pavements that are rated a 7. Pavements that are rated a 7 are candidates for crack sealing. Here's an example of a pavement with transverse cracks. They've opened up enough to the extent that we should do some crack sealing early on in the life of the pavement. A good candidate for this kind of preventative maintenance. Here's another pavement that I would rate a 7. It's in good condition, and just some crack sealing would be in order. This is an example of a pavement that has had a recent seal coat, but you can see it has some life on it now. It's not a brand new seal coat. Some of it is wore off under traffic and probably snowplow action. You would want to consider looking at this and keeping the crack sealing in good condition. Another pavement that we've had cracking, and it's gone to the point that you definitely want to have a good aggressive crack sealing program, but still in good shape. I would rate this pavement a 7. Next, I'd like to move on and discuss pavements that we would rate in a category 6. A pavement that's rated a 6 is one that would be a candidate for preventive maintenance treatments like surface treatments. Here we have an example of a pavement that has the first signs of raveling. You can can see the rough texture starting to develop, and the fine hairline cracks are in the pavement, and now they're closer together. They're probably less than 10 feet apart. Excellent time to do a preventive maintenance like a surface treatment. Here's another pavement that the transverse cracking has continued to the extent that they're only a few feet apart now. Therefore, you're beyond just crack sealing. I think a preventative maintenance like a seal coat would be an excellent treatment for this pavement. You can see here the cracks are still hairline and enclosed. If you look at this pavement, and if you look at the top of the slide, you can see in the far lane the first signs of block cracking, another indication of pavements that would be candidate for surface treatment and would be rated as 6. And block cracking, more extensive block cracking. It's very evident in this pavement, and an excellent time to put on a preventative maintenance treatment like a seal coat. Here's an example of a pavement. Now the crack has opened up a little bit. They're wider than they were before. Again, another indication that you should rate this pavement a 6. Next, let's describe pavements that we would rate a 5. These are also candidates for preventative maintenance treatments like surface treatments, but there is further deterioration. For example, here you can see raveling is now extended. It's more of a moderate raveling occurring in this pavement. Another example of surface raveling, it's gone to the severe extent in the wheel paths. Severe raveling, if you're going to treat it with a surface treatment, you must get at it before it goes too far. That's why I would rate this a 5 and a candidate for a surface treatment. Another example of moderate raveling, let's see the block cracking continuing. Cracks are starting to open up and get closer together. I would rate this pavement a 5. Here's another case of surface raveling on an urban street. This raveling is continuing fairly rapidly now, and I would like to see this seal coated before it goes much further. I would rate this pavement a 5. Here you have block cracking. The cracks are more open and in need of sealing, and if you want to slow down the progression of block cracking, you want to catch it at this point, I would rate this pavement a 5. Here you have a pavement that has been wedged, and this wedging is doing very well. While there was perhaps some surface distress or some cracking along the edge, they patched it, and it's holding up very well. Inherently, this pavement looks sound to me. I would consider it also a good candidate for a surface treatment such as a seal coat. Next, if we look at pavements that are rated a 4, these are pavements that we're going to consider candidates for overlays. Here you see some very severe raveling. Frankly, if it ravels to the extent that you see in this slide, probably a surface treatment is not appropriate. It's gone too far, and we'll have to look at an overlay. Here you see the block cracking is more extensive. The size of the blocks are getting fairly small. The cracks are still tight, and the pavement is sound. I think you'd have a good chance of overlaying this pavement and getting a good life out of an overlay. I would rate this pavement a 4. Here's an example of longitudinal cracking in the wheel path. Remember, this is an indication of strengthening is needed. Therefore, I would consider this a good candidate for a structural overlay and therefore rate the pavement a 4. Another example of a crack, longitudinal crack in the wheel path indicating the need for strengthening. There's other distress, block cracking, and distress to the extent that an overlay would be very appropriate. I would rate this pavement a 4. Here's an example of a patch. This patch is performing very well. This gives me confidence that perhaps we could overlay this entire pavement and catch it before further deterioration occurs. I'd rate this pavement a 4. Now we'll move into category 3, that is pavements that are rated 3 and are in need of not only an overlay, but perhaps some more extensive repair before the overlay can be accomplished. Here's a roadway that has very extensive cracking in the wheel paths. And if you look at the cracks closely, you can see they're wide open. In fact, they've not only tried to seal these cracks, some places are actually trying to patch them. When you see cracking to this extent, there is going to be a problem, in my view, of just simply overlaying this. This would be a great candidate for a milling operation. If you could mill off this crack pattern and then put an overlay on, you'd have a much better performance of the asphalt overlay. You now have more extensive block cracking. The cracks are wider here, and a more sort of a structural overlay would really be appropriate. Here's another pavement that has more severe distress. You can see the longitudinal cracking has even some beginnings of alligator cracking starting to occur. Again, some milling and repair and strengthening of this pavement before the overlay would give you a much better performing maintenance treatment. Here you have some edge wedging that has been done a few years ago, and see the cracking coming back through. This is not performing well, and to me indicates more of a strengthening is going to be required, maybe some deeper strength patching before you get into the asphalt overlay. Finally, you have an example of alligator cracking. In a Category 3, some alligator cracking can be present, maybe up to 25%. These are going to require excavation and patching before the overlay is done, but some level of alligator cracking can be tolerated, probably in this category, before we get down into total reconstruction. Moving down to a 2 category are pavements where total reconstruction is going to be required. Here's extensive alligator cracking over the entire surface. This ought to be milled and recycled, where the material is laid down and maybe added to the base course for strengthening, maybe some additional base is required, and then a new pavement surface is put on. Extensive alligator cracking and patching, there's no way you can get by with overlaying this. You're looking at really total reconstruction. Again, extensive alligator cracking in this pavement. You can see the area adjacent to the pavement is higher than the road. You have no drainage. You have probably very limited base in this particular case. A lot of patching and distress. I would recommend total reconstruction and rate this pavement a 2. Again, another example of a pavement that has pretty well failed, extensive alligator cracking and patching. It really needs to be totally rebuilt. Therefore, I'd put it down into the 2 category. If we move now into our lowest category, pavements rated 1, we're talking about total failure. You can see here that the roadway is broken up, water standing in the road. You have traffic that has to proceed at a very slow speed. Looking at total failure, that's why I would rate this a 1. Another example of total failure, in fact, it's hard to even see some of the asphalt surface left here, need of total reconstruction, rated a 1. One last final example of a pavement that I would rate a 1. You've got water standing in the road, no drainage, really no surface left at all. The lowest category, a 1, requiring total reconstruction. That completes our review of the pavement evaluation and our rating scheme. This training video was developed in order to provide help to you to do your pavement rating and assist you with your implementation of your own pavement management system. I'd really like to encourage you, though, to think about what we've said during this tape and tailor your evaluation and rating system to meet your own needs. You may not use all of the maintenance or repair techniques that we talked about. Therefore, you need to tailor your evaluation to meet the procedures that you're actually using. In addition, you may use other indicators of condition that would trigger for you the need for crack sealing, surface treatment, or overlays. You should be using the experience that you have in your own agency and applying that as you develop this procedure. Once you understand the basic approach, I think you can use your experience to strengthen this and really develop a system of evaluation and rating that's most helpful for your agency. I should also note that we have developed PASER manuals for gravel roads, unsurfaced roads, as well as concrete pavements. And the approach is exactly the same. You could use those manuals directly, I think, once you understand the approach, look at the distress and deterioration typical of those kinds of pavements, and you should be in pretty good shape, I think, in doing your own rating and evaluation along with the use of the PASER manuals. We have a lot of people using this rating system. It seems to be growing in popularity. I think it's because it's straightforward. It uses an evaluation scheme that is very typical that we normally use in our maintenance and repair techniques. And so I'm hopeful that this training video will be an additional step in building your confidence and encouraging you to upgrade the way you're evaluating your pavements, and it will be useful in implementing your own pavement management system. In conclusion, I want to note that this training tape was developed with financial support from the Federal Highway Administration and technical support from the University of Wisconsin-Madison and Michigan Technological University. Thank you and good luck.